Hello, good afternoon, good morning, whatever time it is where you're at. So today's topic is going to be algebraic expressions or variable expressions. We use that interchangeably. If you are um, following along with the note outlines in Blackboard, share that real quick. So again, all my lecture examples are coming from the Student Study Resources Unit 1 and the lecture note outlines. Today we are doing 6.1. Right, so if you want that to follow along with as problems, get that printed off ahead of time. Okay, so this is going to be a pretty straightforward video. There's nothing overly complicated about this. Not to say it's not important, particularly the second part of what we're going to do. But there are two main topics that we're going to be covering with this today. The first one is going to be evaluating variable expressions. Bring up. And then the second part of what we're doing today is the simplifying variable expressions or algebraic expressions. The evaluating part is definitely the more straightforward part. It's really, anytime you're evaluating a variable expression, and notice like here in the instructions, it'll also say for the given values of the variables, we're going to give you the values for the variables. You're going to plug it in, and then it's an order of operations problem. Right. So the main issue the students have with evaluating variable expressions usually comes down to mistakes with negative signs. And so we're definitely going to talk about that and how to use parentheses and deal with that. The second topic, simplifying variable expressions. Right, this is definitely more critical in terms of long-term algebra skills. And so a lot of the skills that we do in this review chapter, order of operations, fractions, solve equations, all that, for later, topics, if you're still working on those skills a little bit, you can still do the later topics and you may get more wrong answers because maybe you're messing up some of the more basic skills. But when it comes to simplifying variable expressions, if you're having issues with this, to me, that is a huge red flag. So for example, like that 4x plus 9x, if you don't know how to, or what really gets you in trouble, it's not so much 4x plus 9x, which is 13x, it's something like 19, when you have that 9a plus 4 minus 5a. And if you're trying to add like the 9a plus 4 and get 13a, that's what we call combining unlike variables. Right? And that's our unlike terms. And if you're doing that, it makes it almost impossible to do anything algebra related. So to me, if you're struggling with this part of this homework, that's something that needs to get addressed immediately. And hopefully, if you are having issues, that you'll contact me so I can help you with it kind of one-on-one. Okay. But before we get into that part of it, let's back up, do the more basic, simple evaluating variable expressions. Okay. All right, so my best tip on this is anytime you're plugging in numbers for variables, please use parentheses, particularly if it's negative numbers. Sometimes positive numbers we can get away with not using them. But if you're not using parentheses and you're plugging in negative numbers, you're far more likely to make mistakes. And so, excuse me, try not to sneeze. So just use parentheses. It's better to have them and not need them than the other way around. All right, so let's start with a basic problem. So we have this 4x plus 3y for x equals 6, y equals 2. And so, the big thing to keep in mind, big picture, is that anytime you have a number right next to a variable, it does mean multiplication. So that means 4 times x plus 3 times y. And so when we plug in that 6 for x, you could put the multiplication dot, but again, I just think it's a good habit to use parentheses. We have 4 times 6 plus 3 times, now y is 2. And so once you do that, that's why I say it's right back to order of operations. Okay. And so hopefully by now you've done your order of operations homework, so you're good with this because we're going to do our multiplies before we do our additions. So that would be 24 plus 6 to give us 30. Like I said, unless there's issues with negatives, these are for the most part, in the order of operation problems, we probably give you messier problems than what you're doing here because we're adding on the layer of putting in numbers. All right. All right. How about number 7? X minus 4YZ. Well, anytime, just like we have a number right next to a letter, it means multiplication. If you have two letters next to each other, that means multiply. So that is 4 times Y times Z. So let's plug them in. We know X is 98, so it's going to be 98 minus 4 times Y, which is 6, times Z, which is 3. Now you may be wondering why I didn't put that 98 in parentheses. Um, so since it is that front number, there's nothing multiplied times X, there's nothing, there's no exponents on X, anything like that. But a lot of times that front number, even if it's a negative, you don't need parentheses. And if you did put them, then you can drop them because there's nothing to multiply. All right, and so now you just, you do a negative 4 times 6, which is negative 24. You write on paper something more. All right, so just like any order of operations problem, we do our multiplies first, and that's a negative 4 times 6. This will be minus 24 times 3, and then negative 24 times 3. And again, you're allowed to use calculators, they're your friends. Negative 72, so we have 98 minus 72, and then that gives us, is that 26? Yep, all right. So that's what I mean when you're evaluating variable expressions or algebraic expressions. It really comes down to order of operations. All right, so let's do a little bit more challenging one. So let's do some that have some negatives in there. All right, let's see where do we want to start? I'm going to come back to 8 and 9 for those exponents. So let's look at number 10. So we have x minus 5 over negative 4x minus 9, and x is negative 3. All right, so one thing to point out here is we have two instances of x, so both of those x's are going to be negative 3. So on the top, we have x minus 5 that goes to negative 3 minus 5. And on the bottom, we have negative 4 times x. We have negative 4 times negative 3 now, and then minus 9. Okay, and so this is where I'm saying, like, I really preach putting the negative number in parentheses, but now on that x minus 5, it becomes negative 3 minus 5. Do we really need that parentheses? Well, that's not negative 3 times negative 5. That's just minus 3 minus 5. And that gives us negative 8. And then on the bottom, order of operations says we got to do negative 4 times negative 3 first. 12 minus 9, which is 3. All right. And so just like with any order of operations problem, but if it's a fraction, once you get it down to this point, then simplify it as a fraction. 3 doesn't go into 8, so it is simplified. And so you can either, that is your answer, or negative 5 by positive is overall a negative fraction. So either negative 8 over 3 or negative 8/3, same thing. But if you have multiple instances of your variable, you're plugging it in on everywhere that it exists. All right. Let's get some exponents in here. All right, so if you look at number 8, we have x squared minus 8x plus y squared. For x, we're going to plug in negative 1. For y, we're going to plug in negative 3. X squared minus 8x plus y squared. And this is where parentheses really come into play. All right, so if you don't put parentheses, and so x is negative 1, so this is what it would look like without parentheses. So what is negative 1 squared without parentheses? Well, if you put, if you put that in a calculator, it's going to give you -1. And the reason it's -1 is because since you didn't put parentheses, calculator is going to, just do what you put in there, and it's going to only do one negative. But here's the thing, x squared means x times x. So if you're plugging in -1 for x, you're doing -1 twice. So you really need those parentheses, because if you don't put those parentheses, you're going to lose that negative in your exponent, and your answer is going to be automatically wrong. All right, so get in the habit of anytime you're plugging in negative numbers, unless maybe it's out front and there's nothing multiplied and you can get away with it. But every time else, put your negatives in parentheses, please. And then -8 times x, which is -1, plus y squared, and y squared is -3. Now we have -1 in parentheses squared minus 8 times -1 plus -3 squared. All right, so now it goes back to order of operations. Okay, so order of operations says do grouping symbols first. Even though we have parentheses, those are not grouping symbols because there's nothing to do inside those parentheses. They're just there to help us with the negatives. So the next thing is exponents. So we need to do -1 squared and 3 squared. -1 squared is +1. And then +3 squared. So -3 squared is 9. So that gives us +9. Then we're done with our exponents. So now we do our multiplication. So -8 times -1 gives us +8. And now finally we're down to just regular addition. So that gives us 9 plus 9 or 18. So I think you can see why I said like the most common mistake with problems like this is dealing with negatives. Not only whether or not you use parentheses, but you got to deal with exponents. You got to deal with multiplications, and so that's just a common theme with these problems. Just watch out for your negatives. All right. Let's do. Let's do number 12. Yeah, problems like 9. We could, I mean, theoretically we could do those, but those are a little bit more college algebra style problems. So you may see a couple of those in the homework, but really, we're gonna do more formula sort of stuff with this, and that'll be on the next page. So let's go ahead and do number 12 to deal with some negative issues, and then we'll go to some word problems. All right, so we have 3x plus 12y all over x minus 2. And we are given x is -4, y is -10. Okay. So let's plug all our numbers in. So 3x becomes 3 times -4 plus 12 times y, which becomes 12 times 10. And then we have x minus, oh, sorry, not x. We have -4 minus 2 in the denominator. And again, I'm not going to put that one in parentheses because that's the front number, and it's not being multiplied by anything, no exponents. So we can do that. All right, so on the bottom, -4 minus 2, -6. Now on the top, we have two multiplications and an addition, so we're going to do that the multiplications first. So 3 times -4 is -12. Now here's where, again, with order of operations, and you have something like this, how do you deal with it? So when we're doing that multiplication, treat that addition sign like a positive. So we're doing a positive times a negative. And so our answer is going to be negative. And then 12 times 10 is 120. If you try to do it and like just do positive 12 times -10 and have plus a -120, then you're making it look a little bit messier. So I get, when I'm multiplying in order of operations, I treat that whether it's positive or negative or abstract as a positive or negative, and that way I just have one sign. All right, we continue with the top. So -12 minus 120 is -132, or -6. Now we have a negative divided by negative, so we know the answer is going to be positive. And then we do 132 divided by 6, and we get 22. Now, in this particular problem, I didn't grab the calculator until the very end. If you're going to use the calculator, I'll say the same thing I did before, I would say with order of operations. Please don't put it on the calculator all at once. It's, especially with these bigger problems, it's easier to make mistakes. So if you're gonna use your calculator, use it for the smaller steps, do it for the multiplication, just break it up. Not only are you getting more learning out of that way, but when it comes test time, if you're doing everything in your calculator, not showing any work, you're not gonna get partial credit if you don't if you get a wrong answer. So if you want potential for partial credit, get in the habit of writing out steps, which means use your calculator step by step. Okay, so that is basic evaluation. Let's look at some word problems, because one thing about this class, there are a lot of word problems. We need to get used to dealing with them. All right, so for this top one, forensic scientists use lengths of certain bones to calculate the height of a person. On the femur F, the bone from the knee to the hip socket. So if you haven't taken your anatomy, there's a little bit of review on that. The following formula applies from H equals 69.09 plus 2.24 F, where H is the height and F is the length of the femur. All right, so what do we do with this? Well, it says find the height of the man with a femur measuring 52 centimeters. All right, so we have the formula. H equals 69.09 plus 2.24 F. So this is what you need to do with word problems is, first of all, what are they asking you to find? Well, when it says find the height, well, H is the height, so that is what we're looking for. So if we're going to find height, we need to know F. What do we know F? Well, the femur measures 52 inches, so we know F. But since we don't know H is the only thing we don't know, we plug in F and then go from. So H is equal to 69.9 plus 2.24. Now F is 52. And so now, especially with decimals like this, I'm grabbing my calculator. That's 69.09 plus 116.48. And we add those for a final answer of 185.57. So that is our H. All right, so when you have these word problems, first of all, don't try not to get overwhelmed, and particularly if you haven't done these in a while. Very often we're going to give you a formula, and then basically what you need to do is what do the letters mean? Right. So it tells you that you calculated the height, so H is height. Then the femur F, so they're telling you that's the length of the femur, and so just kind of break it down piece by piece. All right, so what are we going to do in the next one? W is equal to 0.52 G squared minus 0.05 G plus 7.5. This model is the average weight in ounces for a mouse who is fed G grams of special food per day. May seem weird, but there's probably some scientists out there that did something like this. All right, so use the model to find and interpret the result when G is 11. So they're giving us G, and what are we going to do with this? All right, so, well, what is G? G is how much is fed. And so often when it says interpret in MATLAB, these problems will be like multiple choice. MATLAB isn't always as good at like interpreting questions as it is just, straight math. So to do this, we're just going to plug in 11 for G. Right here. So we have W equals 0.52. Now G squared becomes 11 squared minus 0.05 G. So 0.5 times 11 plus 7.5. Okay. And again, now it's just order of operation. So what does order of operations tell us to do first? Well, there are parentheses, but there's no grouping symbols because there's nothing to do inside the parentheses because those are just for multiplication. So the first thing we're going to do is 11 squared, which is 121. right, now, if you wanted, we could have, at the same time we were doing 11 squared, we could have multiplied the 0.5 times 11. Because, that's the multiplication comes before the add subtract. So a lot of times our add subtracts in these problems kind of work like grouping symbols, kind of breaks up the problem. Or you can just do your exponents. Now we'll do our multiplications. It's really kind of just whatever works for you. All right, these are definitely calculator problems. So 0.52 times 121 is 62.92. Now we have a negative 0.5, or sorry, 0.05 times 11. That's going to give us negative 0.55 plus 7.5. And now we just add from left to right, or add subtract from left to right, and then so that's 62.37 plus 7.5, which gives us 69.87. That's our final answer. So what is that? That is W. Right. So that's and what they want us to do. They wanted us to find and interpret the result. So we found the result that W is equal to 69.87. If we're going to interpret it, and again, this should be multiple choice in math lab. What does that mean? Well, W is the average weight of a mouse, and that fed G grams, so G is how much it fed. So if you feed a mouse 11 grams per day, the expected weight is going to be 69.87 grams. All right. So that is evaluating variable expressions. You're plugging numbers in and then basically just following order of operations. Okay, so that is the first half of 6.1. The second half of 6.1 is simplifying algebraic or variable expressions. So before we get into the actual process, let's talk about the actual terms real quick. So if we look at number 15, how many terms are there in an algebraic expression? Well, terms are the pieces are being added and subtracted. And so if you look at number 15, we have 1, 2, 3, 4 terms. There are 4 terms that are being added, subtracted. What is the numerical coefficient on the first term? The numerical coefficient is that number that's multiplied times your variable. And one thing to watch out for is if there's that positive negative is part of the coefficient. So the coefficient on the first term is a positive 6. Coefficient on the second term is negative 5. Coefficient on the third term is a positive 32. And that fourth term, there's different authors will look at this differently. There is no variable there, so that is your constant term. Some books would also, or some authors would also call that a coefficient. To me, it's not a coefficient because it's not times a variable. It's definitely a constant, and so that's how I'll approach it, just calling it a constant. All right. So next question is, does this algebraic expression contain like terms? Well, to be like terms, you have to have the same variable and the same exponent. Same exponent, same exponent and variable. Okay, so let's practice a couple of these. So we're gonna do a table with like and unlike. And I'm going to give you some pairs, and I want you to see, which group does it go into. So if I was to give you X and 3x, are those like or unlike? Well, they both have X to the first power, so those are like. What about negative 7x and negative 7y. Well, when it comes to these like terms, don't get fooled by the coefficients. Does not matter that the coefficients are the same. They both have a negative 7 coefficient. But this one has an x, this one has a y. Those are different variables. They are not like terms. Okay. What about 6x and 6? Those like or unlike? Well, one has a variable, one doesn't. So they can't have the same variable. So those are definitely unlike terms. What about, let's see, x and x squared? Well, they both have x, but they have different exponents. So it looks like they're related, but they're not the same, right? So those are unlike terms. You know, I can do that for anything, like x squared, x to the fourth. Yeah. They both have x, yes, but they have different variables. All right. What if I give you 3xy and 4yx? Are those like or unlike? Well, the question comes down to, does the order matter? Right, so remember, if we're just multiplying, the order doesn't matter. And so that x times y is the same as y times x. So those are actually like terms. Normally, when we have multiple variables in a term like that, we put them in alphabetical order. So this would be the more common way to write it, but this is not wrong. It's just, like I said, if you write it in different order, they look different. So I would probably write this one as 4xy as well. All right, now if this was an algebra class, we could do a lot more of this and talk about more variables and things. Since this is, for this class, we need just a little bit more basic problems. So I think this gets the idea. The big issue, like these are the ones that I'm really concerned about for this class. You recognize that those are like, and that those are unlike, and then do you know what to do with it? Okay. So let's start with basics. So let's start with 4x plus 9x. Okay, so how do you add those? Well, when you're adding, subtracting, you're basically counting. So when I see that 4x plus 9x, to me that says how many x's do I have? Well, I have 4 here and I have 9 here. So the way that we add this is you're basically taking the coefficients and adding the coefficients. The x is going to stay x. So that's going to give us 13x. You know, that's just like if you had 4 cars and 9 cars in a parking lot. How many cars do you have? You would have 13 cars. Right. So if you're wondering why that didn't go to x squared, you're thinking multiply rules. So if we had x times x, well, by definition, we would use repeated multiplication. So that would be x squared. So if you're multiplying or dividing variables, which is something that we'll get into at the beginning of test 2, then we would change the exponents. All right. For us, what we're doing now, we're just adding, subtracting. So the variable and the exponent do not change. Now, this step of writing the coefficients in parentheses, most people aren't going to do that because once you recognize what we're doing, you just need 4 plus 9. One thing is, if you're ever doing this on the calculator, don't put your variable in the calculator. It's like if you tried to put x in the, like 4x plus 9x in the calculator, excuse me, it has values, like random values stored for your variables. So it's going to give you some weird number. So what you need to know, if you're using the calculator, is you're just adding, subtracting coefficients. So that's what you put in the calculator. You got to know yourself that the x is kind of going to tag along. All right, so if we have negative 3x plus 9x, well, those are both x's. So we're doing negative 3 plus 9, which is positive 6. So then our answer is 6x. All right, so now x minus 2x. What do we do with that? So if you think and put a 1 there, that definitely helps. So anytime you have a variable without a number in front of it, that means 1 of that. And so when you're doing this as subtracting and later we're doing our distribution, it probably, if you haven't done this in a while, I think it would definitely help to put those 1 in front of terms like that. So now it's a little bit easier to see. We're doing 1 minus 2. So 1 minus 2 is -1. So that's -1x. Now, very typically, how we would write this in the final answer is if our coefficient is 1 or -1, we tend to not write the 1, and we would just say -x. It wouldn't be wrong to say -1x, it's more common to put -x. Just like if your final answer was 1x, we wouldn't put the 1 in the final answer, we would just say x. So we kind of use those ones in like the intermediate steps, but not the final answer. So up to this point, we've been combining like terms. So now let's see what happens when we get a little bit more involved. So now we have 9a plus 4 minus 5a. So the question is, what are the like terms? Well, only the terms that have a. So we can only add the a's with the a's, and then that 4 is a constant, so there's no other constant, so we're done with the 4. Now, how do you do this? Well, one thing that I would recommend, particularly when you're beginning, is rearrange it to put the like terms together. And so 9a, now when you're extracting, make sure, if you're rearranging it, make sure that you don't lose any signs. So that's a minus 5a, so make sure you say 9a minus 5a and then plus 4. If you're comfortable leaving them apart, like one thing that I do since I've been doing this a while, in my head, I sort of like mentally underline the like terms. And so then I know I'm looking at 9a minus 5a. For a lot of people, at least initially, like rewriting the problem helps keep track of that. Okay, and so now you do 9a minus 5a, which is 4a, and then bring down our 4. Now the question is, now what? One of the unfortunate things that happens, particularly once we start solving equations, is students don't want to stop here. So often I see students like treat this like an equation and try to like subtract 4 and then get a by itself. But if you notice, the instructions say simplify. It does not say solve. If it said solve, we would want to know what a is. We're not solving. Simplifying means we're just doing the operations that are there. Okay? And so what you have to recognize is that these are unlike terms, so we cannot add them, so we are done. And so that's knowing when to stop or what the answer is supposed to look like is very important. Okay? And like I said, as we go through this, people usually do okay, but once we start solving equations, then this tends to get mixed up. But there's no equals in this original problem. There's no left and right side. It is just a single term. All right. So that is basic adding, subtracting. Okay. So next thing we need to deal with is the distributive property. I don't have notes there, so let's talk about this. There's other properties in math like the associative commutative property. I don't really care if you know the names, like what they are, because you use them without knowing, and that's fine. Distributive property is the one that we tend to expect you to know the name of. And so the distributive property looks like this. If you have a parentheses b plus c, if you distribute it, what does that mean? Well, that means a is going to get multiplied times the b and the c. We get a times b plus a times c. All right, so up till now, we haven't had, like, most of our parentheses have had just there for negative sign regions. Now we're going to have a grouping symbol. And so if you have a number times a grouping symbol, this is when we're going to be doing the distributive property. So let me do a little bit more basic before I jump into the ones on the paper, because those have more negative signs. So what if we have 7 times 3x plus y minus 8? And this is either going to say multiply or it could say simplify. So let's follow order of operations. Order of operations says to work inside the grouping symbol first. So here's our grouping symbol. Can we do anything with this? Well, 3x and y, those have different variables. So you can't do anything. Well, that's just a constant. Right? And so if you're trying to combine these, you're combining unlike terms. And that's what I was talking about with that red flag earlier. If you're combining unlike terms, it makes algebra almost impossible. So you got to know there's nothing to do inside that parentheses. All right. So that means, we've on order of operations, we've done the G for GEMDOS. There's no exponents. So for multiply and divide. So when we're doing distributive property is multiplication. And what we're going to do, and this is how I show my work, is draw the arrows. So we're going to do 7 times 3x, 7 times y, 7 times -8. And so how do you multiply 7 times 3x? All right, so can we multiply them because they're unlike terms? Well, the answer is when you're multiplying and dividing, yes, you can multiply and divide unlike terms. It's the adding, subtracting that you can't. And so the way we're going to multiply these, pretty straightforward. You just do number times number, and then the variable kind of comes along. So 7 times 3x is 21x. Okay. And then when we do 7 times y, again, you may want to put that 1 there in front of the y. And so now we're doing 7 times a positive 1, so that would be plus 7 and then y. And then the last one, now we have a positive 7 times a -8, which is -56. So we have distributed that 7. We have multiplied it by everything inside that parentheses. And then are we done? Well, that's the only x, that's the only y, that's the only constant, so there are no like terms to combine. So we're done. Okay, so when distributing positive numbers, usually we're okay. It's distributing negatives that can cause a problem. So again, let me do a couple of small examples before we jump back to the notes. So how about -2 times -6x minus y? So for simplifying this, again, inside the parentheses, there's nothing we can do because those are unlike terms, so we cannot add or subtract those. So we're going to do -2 times both of those. So when it comes to distributing a negative number, usually the first number is fine. Okay, because we have -2 times a -6, so that's positive 12. So positive 12x. The most common mistake with distributing, bigger with negatives, is students won't distribute the negative to everything else. Okay, so again, you may want to put 1 there. So essentially what we're doing is we're multiplying -2 times -1. It gives us a positive 2 or a positive 2y. So please when you're distributing negatives, you need to be a little bit more careful with the later terms in the distribution. Those are unlike terms, so we're done. Let me give you one more quick example and then we'll get to some of this. So what if you have negative parentheses x plus 8? What does that negative outside mean? Well, when I see a negative by itself outside a grouping symbol, I see that as opposite of. And so what is the opposite of x plus 8? Well, opposite of means we change the signs. So if you look at it that way, opposite of negative, or the opposite of positive x would be negative x. The opposite of positive 8 would be -8. So when you have a negative sign outside of parentheses, that means what's inside the parentheses is going to change the signs. They all have to change. So positive, positive to negative, negative. Now, a lot of students, instead of doing opposite of, they prefer to make that a -1. Because the negative sign that's opposite of is like multiplying by -1. Then if you distribute, let's put a 1 there. So -1 times +1 is -1 or just -x. And then -1 times +8 is -8. So when you have a negative outside of parentheses, either it's opposite of or multiplied by -1, whichever way makes more sense to you. But everything inside that parentheses is changing signs. Just like up here, even though it wasn't just opposite of, it was a -2, but because of that negative, we went with negative is where we started. Now we're with positive. So when you're distributing a negative, whether it's just a negative sign for opposite of or a negative number, change to all those signs. All right, let's get back to some messier examples. All right, so number 20, we have -3 parentheses 2x minus 5 minus 4x plus 8. And we're going to simplify these. All right, so what do? Order operations says work inside grouping symbols, but when you look at 2x minus 5, those are unlike terms, so we can't do anything with it. So there's no exponents in this problem. So now we're into multiply and divide, which means we're distributing. So here's my question. What is going to get multiplied by that -3? Is it everything, or is it just the 2x minus 5? So this is where you have to be careful. The parentheses matter. So parentheses, that -3 is right next to parentheses. So only those two are going to get multiplied by -3. Those, they're just kind of, hang out for now. So if you distribute that -3, that gives us -6x. And then negative times negative gives us a plus 15. And now we just bring down our -4x plus 8. So we've done the distribution. So that's the multiply and divide level of order of operations. There is no more multiply and divide. So now we're down to add and subtract. So this is where, again, the key idea of combining like terms is critical. Okay, so when you look at the like terms, we have the x's, and then we have the constants. So only add x's to x's, constants to constants. I can't stress that enough for adding subtracting. Now, like I said, for me, I like underlining them just because that visually that works for me. If you want to rearrange it, by all means do so. So let's start with -6x. Now that is a -4x, so don't lose that minus. And then we have plus 15 and plus 8. If this helps you with your like terms, then by all means do so. And so now we just do x's with x's, numbers with numbers. We have -10x plus 23. And then those are unlike terms. So we stop. All right. And again, I really wish I could pause and ask for questions. That's not possible in this case. All right, so let's do one more of these. Let's do 21. So now we have -9 parentheses 7x plus 4 plus 2 times 7x plus 4. All right. So what do we do with this? Well, now again, nothing to do inside either grouping symbol. So now we go to our distribution. And again, you may want to put those multiplication dots to remind you. So in this case, we have two distributions to do. We have -9 times both of those, and +2 times both of those. So -9 times 7 is -63x. -9 times +4 is -36. Now you notice that we're multiplying by negative and both those signs changed. Originally they were positive, now they're negative. Now for this, we're doing +2 times 7x, that's a plus 14x. Or since it's a positive, make sure to put that plus. If you don't put the positive, then it looks like you're multiplying the 36 times the 14x. And then 2 times +2 times +4 is +8. So when you're doing problems like this, you do your distribution first, and then add, subtracting, combining like terms second, because distribution is the higher order. And now we combine our like terms. So we have negative 63x plus 14. Those are opposite signs, so now we're subtracting. So we're going to get negative 49x. And then we have negative 36 plus 8. Again, we're subtracting, bigger number's negative, so minus 28. Those are unlike terms. So you're done. All right. So this is 6.1. It's the evaluating variable expressions and the simplifying the algebraic expressions. So the evaluating is plug numbers in, do order of operations. The simplifying variable expressions is combining like terms, or for the longer ones, you're going to have to distribute. And then often after you distribute, you have to combine like terms. Sort of depends on the problem. But you definitely want to have like this sort of skill done and solid and be comfortable with it before you start solving equations, which is our next topic. Okay. Have a good day.